Hey guys, hope you're well. Equations of motion, one of my favorite sections. Now, if you're a student that has looked at this in class and you're feeling a bit confused, trust me, it's beautiful, this section. Let me take my time in this lesson and I'm going to do a whole bunch of examples with you where we're going to go over this and see exactly how it works. Okay, so it's 4 formulas that we have. These are usually given to you on your formula sheet in an exam, and so all you need to know is what each thing represents. So whenever you see a VF, that stands for final velocity. Okay, whenever you see a VI, that stands for initial velocity. Whenever you see an X like that, it stands for displacement. Whenever you see an A, it stands for acceleration. And then whenever you see a T, it stands for time. Now, there are going to be some type of questions where more than one formula will work. Then you can use whichever one you like. You mustn't think that you only have to use the correct formula. Sometimes there's going to be more than one option available. Okay, but as we go through this lesson, I will make this very, very clear for you. So all I want you to do, so here we've got the 4 formulas again. And all I want you to do is read the question and then just go highlight whatever we have. So it says that a car starts from rest. If your car starts from rest, it means that your starting velocity, which is your initial velocity, is 0. Okay, so we have initial velocity. So I want you to go highlight initial velocity over here. Okay, so we'll highlight all of those. Then it says accelerate to the right at, so they've given us acceleration. This is an acceleration. So let's go highlight all of the A's, A, and A. Fantastic. How fast will the car be moving after 9 seconds? They gave us time. So go highlight all of the time. Okay, there and there. And then the question I want you to do in a different color. How fast will the car be moving? How fast? So they want to know, what is VF? What is VF? So highlight that in a different color. VF, VF, and VF. Okay, now I want you to look at these 4 formulas and I want you to see which formula has everything highlighted. Well, if you look at this one, this part is not highlighted, so we won't use that one. If you look at this formula, that's not highlighted. I forgot to highlight the T there. Okay, I should have highlighted that T as well. But if you see, we can't use this formula because that's not highlighted. And then if you look at this one, we can't use this formula because that's not highlighted. But if you look at this formula, look at that, it has everything highlighted. So that is the one we're going to use. So in your test, you would go write it down. VF is equal to VI plus A delta T. Then choose a direction as positive. So they said that the car is accelerating to the right. So I'm just going to choose right as positive. It will just make our life much easier. Okay, so we don't know what the final velocity is. The initial velocity is 0. Remember we said over there. Then you're going to say plus A. Now A is 2. So you're just going to say 2. And then the time is 9. So there. And if you had to go calculate that, you're going to end up with 18. Now, what is the units of velocity? It's meters per second. Now, if you get a positive answer and you chose right as positive, then you can just say to the right. Okay? And so that is what we are going to be doing for this lesson. You're going to be taking the question, highlighting the different parts, choosing the right formula. Sometimes in this lesson, we're going to be doing questions where you're going to have to use more than one equation at a time. We're going to have to use 2 at a time. Okay? But I'll show you that as we go along. So here's our next one. A car driving at 10 meters per second. Okay, so that would be the initial speed. So we'll say that that's the VI. So let's go highlight all of our VIs. VI, 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 because we don't know what formula we're going to use, okay? Then it says it's driving north and it applies brakes and reaches a speed. Okay, so this is the final speed. Okay, so we go highlight all of the final speeds. Final speed and final speed. And then let's just say here, final speed. How long does it take? 4 seconds. They've given us time. So we go highlight all of the time, time, and that's it. Okay, then it says, determine the acceleration. Okay, so that's what the question wants us to find. So highlight that one in a different color. So they want acceleration, acceleration, acceleration. Now look for a formula that has everything highlighted. Once again, it's going to be this one. Okay, so what we'll do is we'll choose a direction, or let's first write down our formula. Vf is equal to Vi plus A delta T. Choose a direction as positive. I'm going to just choose north as positive. North is positive. And so we can go fill everything in now. So the final velocity was 2. The initial velocity was 10. The acceleration we don't know, and then the time is going to be 4 seconds. So we do that. Now you need to solve an equation. So this is going to say 2 is equal to 10 plus 4a, and then you need to get a by itself. So I'll take the 10 to the left, for example. So you end up with 2 minus 10 equals to 4a, and then 2 minus 10 is minus 8, like that. And then to get a by itself, we divide both sides by 4. And so a would be negative 2. So the way that you write that then is you change it to a positive 2, and then you put the correct units for acceleration. Now we chose north as positive, but we got a negative answer. So we're going to say south. 2 meters per second to the negative 2, south. Here's our next example. An aeroplane is coming into land. It hits the runway at 60 meters per second. So that's your initial velocity. So let's go highlight initial, 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 and initial velocity. How long does the runway need to be in order to bring the aeroplane to a stop in 15 seconds? Okay, so they want to know how long does the runway need to be. So if the aeroplane lands over here, big aeroplane, and then it needs the long runway, and they want to know how long must that distance or that displacement be so that the aeroplane can come to a stop. Ooh, we didn't even look at that. If an aeroplane comes to a stop, that's the final velocity. The final velocity is 0. If you stop, then you're not moving. So they've given us the final velocities, and they also gave us the time, 15 seconds, so we can fill in the time. And they would like us to calculate the displacement, which you can think of it as distance when we're moving in a straight line like this. Now, if you look carefully, you'll see that there is no formula that has everything available to us. Can you see that? There is no formula that has everything highlighted. So what do? Do we just abandon the question? No, I told you in the beginning of this lesson, sometimes we're going to need to use 2 formulas. So for example, this formula looks quite nice. The reason I say so is we're trying to find this one, and all that's missing is what's missing, guys? A. So what we can then do is we can go up to this formula, and because we know this, and we know this, and we know this, we can then use this equation first to find A, and once we find A, we can then come back down to this equation and just use that one over there. Because you can't use this equation because you don't know 2 things. You don't know what that is, and you don't know what that is. You can't use this equation because you don't know what that is, and you also don't know what that is. So there's 2 things you don't know. And you can't use this equation because you don't know that, and you don't know that. But we can use this equation because there's only one thing that we don't have. So we'll use this one, and then once we have A, we can plug it over there, and then we can solve the rest of the question. So let's go Vf equals to Vi plus A delta T. Now they haven't given us any direction. That's okay. Sometimes they don't. So what we'll do is we'll say 0 equals to 60 plus A, and then T is 15. Now, if you had to say 0 is equal to 60 plus 15, 60 plus 15a, then to get a by itself, you can take the 60 to the other side where it will become a negative. Now, to get a by itself, you divide both sides by 15. And you end up with, because this 15 then cancels, and you end up with a equals to -4. Why is the acceleration negative? Well, think about it. When the aeroplane lands on the runway, we need the aeroplane to start slowing down. So we don't want it to be accelerating. We don't want by having that negative acceleration, it means the acceleration is in the opposite direction to what we were moving. And so in this kind of scenario, it would mean that we are slowing down. And so we could say, therefore, acceleration is going to be equal to 4 meters per second. And then we can just say here, in opposite direction of motion. Now here is the most important thing that I need you to understand when we go to this next step over here. So we're going to go use that formula now. Now, remember that if the aeroplane, for example, is going in this direction over here, so it lands over here, and then it's going in that direction, okay? Now, we need to find the distance of that runway. So we know that the initial velocity was 60. We know that the time is 15, so we filled in that and we filled in that. Then we say plus half. Now, for your acceleration, you must put it as a negative, because remember, the object's going in this direction, so you're almost thinking of that as the positive direction, but the acceleration is 4, but in the opposite direction. Remember, we even got a -4 for the A value. So you're going to put a -4 over there. And then for the time, you're going to put 15 to the power of 2. Now, if you had to go calculate this, you end up with 450 meters. 450 meters. If you got a different answer, it's probably because you put a +4 over here, but that's not correct, because using a +4 over there, then you're saying that the aeroplane is becoming faster and faster and faster. And so you must make sure that this is the final answer that you got. Here's our next one. This is a good question because it gives us kilometers per hour, and we need to learn how to change that into meters per second, because that's what the units that we work with. So Vusi is busy driving at 72 kilometers per hour, and the robot turns red. So he's busy driving, and suddenly there's a robot in front of him that turns red. He is 40 meters from the robot, okay? What acceleration will he need in order to stop in time? Okay, so we've got a person called Vusi driving in a car, and the car is driving at 72 kilometers per hour. That is the initial velocity. Obviously, we need to first change it to meters per second, but we do have initial velocity. So we can say we've got initial velocity, initial velocity, initial velocity, and initial velocity. He is 40 meters from the robot. So that is how far he is going to drive. That is how far he will go before he gets to the robot, where he has to then stop. Okay? So we have the displacement. It's 40. Displacement and distance is very similar in this section. Okay? And then it says, what acceleration will he need to undergo in order to stop? If your car stops, then it means your final velocity is 0. So we have final velocity. We have that. So we can go fill that in. And then it says, what acceleration does he need? So we are looking for acceleration. So what is acceleration? All right, so if you look at all the formulas, we're not going to use this one because we don't have that. We're not going to use this one because we don't have that. We're not going to use this one because we don't have the time, but we can use this one because everything is filled in. So we can just say Vf squared equals to Vi squared plus 2a delta x. But now we need to first change kilometers per hour to meters per second. The way that you do that is you just do the following. You divide by 3.6. That is what you do. So you're going to take 72 kilometers per hour. You're going to divide it by 3.6, and that is going to give us 20. And that is what we will use. So the final velocity is 0. Remember, we said that Vusi is going to stop. The initial velocity is 20. Now remember, there is a little square over there. That's important. A lot of learners forget that. The A we don't know, and then the displacement is 40. Okay, now what you do here is you just multiply everything together. So what is 2 multiplied by 40? Well, that's going to give you 80. and then 20 to the power of 2, that's going to give you 400, and then this just gives you 80a. Now to get the a by itself, you take the 400 to the left. Now you divide both sides by 80 and divide by 80, and then you end up with a is equal to -5. Now the -5 for the acceleration, that should make sense because we're slowing down. The negative tells us that the acceleration is in the opposite direction to what we are moving. Okay, so in these kinds of questions, a negative acceleration will tell us that we're slowing down, but that's not always true, as I've showed you in previous lessons. But in these equations of motion ones, then that's usually what's happening over there. So what we can then do is say a is equal to 5 meters per second to the -2, and then just say in the opposite, because they didn't tell us left or right is positive, we'll just say in opposite direction of motion. Here's another one. An aeroplane is taking off from rest. If you take off from rest, your initial velocity is 0. So we have an initial velocity. There we go, and there we go. It needs to reach a velocity of 80. Okay, so that's our final velocity that we need to reach. So we've got the final velocity. What acceleration does the aeroplane need in order to reach the velocity in 700 meters? Okay, so that is your displacement. So we've got displacement, and displacement. Now they said what acceleration? Okay, so what is A? They want us to calculate A. So we can just go fill that in. A, and A. And so if you look at the formulas, we can't use this one because there's no time. We can't use this one because there's no time. We can't use this one because there's no time. But we can use this one. And so we can say Vf squared equals to V initial squared plus 2a delta x. And the final velocity is 80. Remember, the aeroplane is now taking off. So it starts at 0 and then builds up its speed so that it can reach 80. Then the initial velocity was 0. The acceleration we don't know. And then the displacement is 700. So if you type this on your calculator, it'll give you 6,400. Okay, then 0 to the power of 2 is just 0. And then this becomes 2 multiplied by 700, which is 1,400a. Okay, now 0 just doesn't really do anything, so we just do that. We can actually just write it like that. Now to get a by itself, we divide both sides by 1,400. And so on the left, we end up with 4.57. And then on the right, these cancel, so you just get A. So that means A is going to be 4.57 meters per second. And then we can just say in original direction. Because we got a positive answer, they didn't give us what positive and negative is, so we can just say in original direction. Okay, and so it makes sense that the aeroplane has a positive acceleration in this scenario. It's going with the original direction because the aeroplane is going from 0 up to 80 meters per second. Here's our last one. Craig is busy driving at 20 meters per second. Okay, so that's the initial velocity. Initial velocity. So if we go highlight that, initial, 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 and initial. And suddenly sees a person walk into the road 30 meters in front of him. Okay, so Craig is busy driving his car over here, and then 30 meters in front of him, someone walks into the road. Okay, so we have and it says Craig's car can slow down at an acceleration of that. Will Craig be able to stop in time? Okay, so let's pretend that Craig will stop in time, so that the total displacement is going to be 30. So we'll take that as 30, so we have that. They then say Craig's car can slow down at an acceleration of -4. The negative is just because we are going to be slowing down in this type of scenario. So we have the acceleration. We can go fill that in. Will Craig be able to stop in time? Now I'm going to show you a little trick in this question, okay? This one's a little bit of a sneaky one. We know that Craig needs to stop. So that means the final velocity will be 0. But we don't know if Craig will stop in time. We don't know if Craig's going to be able to stop in time. So we don't know. So what we can do is we can then go, we can then actually use this formula over here. And what we can do is calculate the final velocity. And we want to make sure that Craig's car will be able to reach 0. Let's see what Craig's final velocity is going to be. So we could say Vf squared equals to V initial squared plus 2a delta x. Now we can say that we don't know what the final velocity is. We hope it's going to be 0 so that Craig can stop before he hits this person. But let's see. So the initial velocity is 20, and there's a to the power of 2. Now the acceleration is a negative number, so remember that. And then the displacement is 30. Okay, so if you had to go work this out, you're going to end up with 400 minus, that's 240 over there. So then Vf squared is going to be 160. Now to get so if you've got Vf squared equals to 160, then to get the final velocity, you have to take a square root. And if you take the square root of 160, you end up with 12.65 meters per second. So what that means is that, unfortunately, sorry guys, this is a bit of a graphic question, but this person's going to be bumped over because Craig is driving at 20 meters per second. By the time he covers 30 meters, he's only driving 12.65 meters per second. So his car has not come to a stop. So he is actually going to collide into that person. So will Craig be able to stop in time? No. Hope that makes sense. So what we did is we went and calculated his final velocity, and we realized that it's not going to be 0. It's going to be 12.65. So his vehicle is not going to stop in time.